Today, we are going to travel back in time, way back, to a period that was absolutely transformative for primate evolution. This was a time when the ancestors of every single monkey, ape, and human first began to really take off. Our destination? The Oligocene epoch. The Oligocene epoch, spanning approximately 34 to 23 million years ago MYA, represents a critical juncture in primate evolutionary history, distinguished by the significant diversification of the anthropoid primates, monkeys and apes. The primary feature of the Oligocene, in terms of primate evolution, was the widespread adaptive radiation of the anthropoidea. So let's dive in and see what this incredible evolutionary explosion actually looked like.
All right, here's how we're going to break this down. First, we'll look at the dawn of the anthropoids. Then, we'll journey to an ancient fossil forest in Egypt that has given us so many clues. We'll meet a key primate family, the Propleopithecids, and their most famous member, Aegyptopithecus. We'll see how this creature emerges as a common ancestor, leading to a huge split. And finally, we'll look ahead to what comes next, the Age of Apes.
Okay, so to really get a grip on the Oligocene, we actually need to take a tiny step back to the very end of the epoch that came before it, the Eocene. It's right here that we start to see the very first hints of our own lineage, the anthropoids, beginning to appear on the scene.
You know, what's so interesting is that the story of anthropoids doesn't just kick off neatly on day one of the Oligocene. The very first fossils that signal their arrival actually show up in the late Eocene, just before that 34 million year ago mark when the new epoch officially begins.
And what's really fascinating here is where these first fossils pop up. We've got Eosimias found in China, Pondungia in Myanmar, Siampithecus over in Thailand, and then all the way across in Libya, we find Briechia. This tells us it wasn't just some small, localized event. It was a huge, widespread debut happening across two continents, a clear sign that a major evolutionary shift was getting started.
So, from that really broad, continent-spanning view, we're now going to zoom way in, focusing on one specific place that gives us this absolutely incredible, detailed window into that ancient world. I'm talking about the Fayum beds of Egypt.
If you were to go to the Fayum Depression today, you'd find a stark, dry, arid desert. It's a pretty harsh landscape, and it seems like the last place you'd expect to find clues about our primate ancestors. But that modern view is very deceiving.
Because if you could wind the clock back 30 million years, that same exact spot was a completely different world. It was a lush, green, tropical forest, a vibrant, wet ecosystem filled with an amazing diversity of life, including a spectacular variety of early primates. And that rich environment is exactly why it preserved such a phenomenal fossil record for us to discover.
Now, inside that incredible ancient forest, the fossil record shows us three major branches of anthropoids were really diversifying. You had the Oligopithecidae, which is kind of an early side branch. Then there were the Parapithecidae, a group we think is ancestral to the New World monkeys we see in the Americas today. And finally, the family we're going to focus on, the Propleopithecidae.
We're zeroing in on the Propleopithecidae because they are just so important to our own story. Here's the bottom line. This is the group from which all catarrhines, that's all Old World monkeys and all apes, including humans, would eventually descend. And within this really crucial family, there is one genus in particular that has become the absolute star of the show at the Fayum fossil beds. It's given us our clearest look yet at a common ancestor.
Meet Aegyptopithecus zeus. This creature is a true cornerstone for our understanding of the divergence that would go on to shape our entire primate family tree.
All right, let's run through the key details. It's part of the Propleopithecacea family, found right there in the Fayum beds of Egypt, and it lived during the Oligocene. What's so cool is its morphology. It was this fascinating mix. It was a slow-moving, tree-dwelling quadruped with a body like a monkey, but its teeth, its dental formula was like that of later apes. The significance here is huge. It's our best candidate for a common ancestor to all Old World monkeys and apes.
So finding Aegyptopithecus is a huge deal because it helps us pinpoint this massive split in our own evolutionary story, what we can call the Great Primate Divergence.
And just so we're all on the same page, when we say Old World anthropoids or catarrhines, we're talking about a massive group. It includes all the monkeys from Africa and Asia, like baboons and macaques, and all the apes, gibbons, orangutans, gorillas, chimps, and yes, us humans. That's the lineage we're talking about.
Aegyptopithecus is positioned right there.
at or very near the base of that critical split. It represents the ancestral form just before the evolutionary path forked, leading to the two major groups of primates that are so successful today. This really illustrates that classic fork-in-the-road moment in evolution. You start with an ancestor, something like Egyptopithecus. Then a divergence happens, and the path splits. One of those paths leads to the incredible diversity of Old World monkeys we see today. The other path leads to the apes, the hominoids, the lineage that ultimately includes us.
So, as the Oligocene comes to a close, everything is perfectly in place for the next epic chapter in primate evolution, which is all going to unfold in the following Miocene epoch.
While the earliest anthropoids were more monkey than ape-like, the apes or hominoids were the first to successfully adapt to changing environmental conditions in Africa. And that's really the key takeaway here. Even though that ancestral form looked more like a monkey, it was the ape lineage that had what it took to thrive in the world that was coming.
Crucially, while the earliest anthropoids discovered were anatomically more monkey-like than ape-like, the apes, hominoids, were ultimately the first group to successfully adapt to the changing environmental conditions in Africa, which set the stage for the subsequent Miocene epoch, often characterized as the Age of Apes. We will talk about them in next video.